Today we will start with special reactions of phenols, and thus first is Kolbe's reaction. It can be asked as discuss Kolbe's reaction for phenol or write Kolbe's reaction for phenol. It can be asked in any form. In discuss, that is we have to write in detail. Write Kolbe's reaction, just we can write in shortcut. So when sodium phenoxide is treated with carbon dioxide at about 400 Kelvin and 4 to 7 atmosphere pressure, sodium salicylate is formed, which on acidification gives salicylic acid. This reaction is Kolbe's reaction. In this, para product dominates. Ortho and para both are formed, but para product dominates. So, and now here is acidification. It is Di. So reaction is sodium phenate. In this, hydrogen is replaced with sodium, so it is sodium phenate or sodium phenoxide with carbon dioxide at 400 Kelvin. At this pressure, it gives this phenyl sodium carbonate, CO3, so it is a carbonate. And rearrangement, it rearranges to this group, moves to ortho position, that is COONA, and it is sodium salicylate, and then with HCl it gives salicylic acid, that is sodium is replaced with hydrogen. So this is Kolbe's reaction, and with which sodium phenate is treated with carbon dioxide at 400 Kelvin at 4 to 7 atmosphere pressure, and then this phenyl sodium carbonate is formed, which rearranges to give this sodium salicylate, and then in the presence of HCl, sodium is replaced with hydrogen and sodium chloride is removed, and this is salicylic acid is formed. Now next comes the Reimer-Tiemann reaction. Write the reaction involved, equation involved, how will you convert phenol into sessaldehyde. That is, in this, phenol is treated with chloroform in the presence of aqueous sodium hydroxide at 340 Kelvin, followed by hydrolysis gives aldehyde group at ortho position, and this reaction is called Reimer-Tiemann reaction. Combines with chloroform in the presence of NaOH to give sodium phenate and CHCl2 group at the ortho position. In this, H is replaced with sodium, and here one Cl is removed and then H is removed. So H combines with this OH as water is removed, and on the other hand the Cl combines with sodium and NaCl is formed. So phenol combines with chloroform in the presence of sodium hydroxide at 340 Kelvin temperature to get this product, and in this, in the presence of sodium hydroxide, this Cl groups are replaced with OH groups with aqueous sodium hydroxide. As we already know, halide group is replaced with OH group with aqueous NaOH. Now when two OH groups are attached at single carbon, that is this, two OH groups are attached, then this is unstable, compound is unstable, and in this water is removed as OH and hydrogen, and here only oxygen is present, and then it will be attached by double bond, that is this unstable. Now by removing water we get this product, that this is aldehyde group, this C double bond O, and hydrogen is already present, so it is aldehyde group at the ortho position. And when it is treated with dilute HCl, then this sodium is also replaced with hydrogen, and we get sessaldehyde, ortho sessaldehyde, that is OH and aldehyde group is present and they are at the ortho to each other, so it is ortho sessaldehyde. So phenol can be converted to acetaldehyde, or we can write the Reimer-Tiemann reaction. Now it is also in one paper, write the structure of 2-hydroxy benzoic acid and write its common name. So it is 2-hydroxy benzoic acid and its common name is salicylic acid. Now here I is missing. So next is the coupling reaction. Coupling reaction means how does phenol react with diazonium salt, and or it can be asked as write the reaction when phenol react with benzene diazonium chloride. Benzene diazonium chloride, or it can be directly taken as diazonium salt. So what is coupling reaction is? It is the ice cold solution of phenol when it combines with ice cold solution of benzene. That is ice cold solution of phenol when it combines with ice cold solution of benzene diazonium chloride. It forms a colored substance azo dye. Forms colored compound azo dye. This reaction is called coupling reaction. So phenol with diazonium salt in the presence of weakly acid alkaline medium, that is around 9 to 10, it forms azo dye. Azo means N double bond N is present, then it is called azo. So it is para-hydroxy azobenzene. Para-hydroxy, OH group is present para to this, and this is azo group and these are the benzenes. So it is para-hydroxy azobenzene and it is of orange color, so it is a orange dye. And in this, phenol is written in way that OH group is outside, shown outside, and here is hydrogen present. This hydrogen and Cl of diazonium chloride are removed, and this N2 is directly linked to this benzene through double bond N, double bond N, this. So it is a coupling reaction. So next is Phthalate reaction. This is also very important. Phthalate reaction is when phenol reacts with phthalic anhydride in the presence of concentrated sulfuric acid to give phenolphthalein. This reaction is called Phthalate reaction. In this reaction, this is phthalic anhydride, that is benzene ring, then two ortho groups, C double bond or C double bond group is attached, and this is joined, that is O. This is anhydride group, this group is anhydride, and these are ortho to each other, so it is phthalic anhydride. Otherwise it is COH, that is phthalic acid, and they are attached through oxygen. It is a phthalic anhydride. When it is treated with 2 molecules of phenol, phenol is OH group is attached here, OH group. So through the opposite side, these hydrogens and this oxygen of anhydride are moved as a water, and these benzene rings get directly attached to this carbon in the presence of concentrated sulfuric acid. This is an important condition, and to give this, these are the two phenol groups. Through hydrogen, these are attached to the carbon which were having double bond. So it is phenolphthalein. It's very important. That is, this is phthalic anhydride with 2 molecules of phenol in the presence of concentrated sulfuric acid. These 2 rings gets attached directly to the carbon, and this water is removed. That is, it is shown as this. So it is phenolphthalein, which is used as a indicator in the titrations. So next is condensation with formaldehyde. Phenol with formaldehyde in the presence of dilute acid or alkaline give cross-linked polymers called bakelite, which we have done in polymers. So next is reaction with ferric chloride. Phenols react with ferric chloride to give colored water-soluble complex compounds. Different phenols give different colors. This is the simplest phenol, and it gives a violet complex with the ferric chloride. Now reaction with hydrogen in the presence of nickel, then these double bonds are removed and the hydrogenation is done. Hydrogenation means hydrogen is added across the double bonds and it is called reduction. In the addition of hydrogen in the presence of nickel at 430 Kelvin, these three double bonds gets hydrogenated and therefore three hydrogen molecules are used and we get, now this is not a benzene ring, now it is a hexane and it is cyclohexane with OH, so it is cyclohexanol. It is ring, so it is cyclo. It is simple 6 carbons in a chain, so it is a hexane. Now OH group is attached, so E is replaced with OL, so it is cyclohexanol. Now next is the oxidation. Oxidation with potassium dichromate in the presence and sulfuric acid, it gives parabenzoquinone, that is with potassium dichromate and sulfuric acid we get this compound, this is parabenzoquinone. And if oxidation is done with potassium persulfate, that is K2H2O8 in alkaline solution, then this reaction is called Alps persulfate oxidation. Alps persulfate oxidation, it can be asked in naming reactions, and we get catechol and quinol as the products, that is OH groups are attached in this or to ortho positions and in this para positions. So phenol with K2H2O8 gives 1,2-dihydroxybenzene, 1,4-dihydroxybenzene, and these are also called catechol and quinol as the products. So it can be asked how phenol can be converted into benzoquinone, we can easily write. Now next comes the Lieberman's test. This can be used for a distinction test for the secondary alcohols. On warming phenol with sulfuric acid and sodium nitrite, brown or red color is obtained, and then this color changes to blue or green by the addition of aqueous sodium hydroxide, that is phenol with HNO2 gives this, which in dynamic equilibrium with this complex, and then this with phenol gives, in the presence of sulfuric acid, gives this endophenol, and this in alkaline medium gives blue color, that is sodium salt of endophenol, in which OH, this H is replaced with sodium group. So this phenol gives this color, but alcohols did not give. Now comes the test to distinguish phenol and alcohols. We have done so many tests by which we can easily distinguish, that is with ferrichloride, Lieberman test, and then coupling reactions, then benzoquinone from phenol. Now how would you obtain benzoquinone from phenol? We have already done this in previous reaction. Now this can also be written, that is phenol 2,2,4,6 tribromophenol. We have done in aqueous bromine, we get tribromo phenol. Then how to convert phenol into salicylic acid, benzene, picric acid, aspirin, this can also be asked. This can be, you can go through just this. And then there's the phenol uses. It is used as a preservative for ink, for the manufacture of azo dyes, in the manufacture of picric acid used in making explosives, then in the manufacture of drugs like aspirin, cellulose, etc., and then for preparing phenolphthalein reagents. And so it's all about the phenols, special reactions. Thank you.